Okay, so we are talking about the automata, finite automata with output. So, we have seen two machine which is Moore machine and Mealy machine. Just to recap, and then we'll just go for the equivalency between two. So, just to recap, the Moore machine is, it is a 6 tuple. So, every we have an output here. So, this q is the finite number of states, this is the input alphabet, this is the output alphabet, and we have a delta. Delta is the state transition function which is taking the input alphabet and which is changing the states, and we have lambda. This is a output function for output and q 0. So, 6 tuple. So, this is a delta is q cross sigma to q like DFA, and lambda is q to. So, every state is outputting a output symbol. So, this is the set of output symbol, everything is finite over here. So, this is the set of output symbol which is outputting a output symbol. So, now if we have to read a string, suppose we are going to read a string say x equal to a1, a2, an. Okay. And suppose, so we start with q 0, say we start with q 0, we go to q 1 with a 1, q 2 like this. So, dot 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 n we are going to q n. So, this is the input, this is the input, and these are the state it is going by the rule of delta. Now, what will be the output? Output will be, then we have a delta of q 0, lambda of q 0, because this is the first state, then lambda of q 1, lambda of q 2, lambda of q n. So, this is of length n, but the output sequence of Moore machine is of length n plus 1. Okay. And we have seen an example where we have seen an example of the Moore machine. We can take the example quickly again. This is just to recap of the previous lecture. Say for example, we have a message, we have 0 1 is the input alphabet, 0 1, and we have the delta rule is like this. Q 0 is the starting state, with 0 it will go to q 3, with 1 it will go to q 1, and lambda is like this. So, lambda of q is q 0 for it is 0, and q 1 say it is going to q 1 q 2. So, lambda of q say for 1 it is going to, this is q, and then q 2 q 3. So, q 2 it is for lambda, it is q 2 q 3 and it is 0, and q 3 q 0 and it is 0 for q 3. Okay. So, now suppose we are reading a string like this, say our input string is 0 1 1 1. So, we are starting from q 0, with 0 we are going to q 3. Now, with 1 from q 3 we are going to again q 0, and with 1. So, this is 0 1, from q 0 with 1 we are going to q 1, and from q 1 with 1 we are going to q 2. So, what is the output then? Output is, so with 0 we are going to, this is the outputting 0, this q 3 is 0, and q 1 again 0, outputting q 1 is q 0 is 0, outputting it is 1, it is 0. So, output is, this is input and the output is this one 0 0 0 1 0, 5 length, and this is of length 4. Now, when we talk about the Mealy machine, then that will be of the same length. So, just quickly recap, then how do you mean by equivalency? So, that means we have to remove this, then we will see whether they can output the same string. Okay. So, let us just quickly have the Mealy machine. This is the Moore machine we have seen. The Mealy machine is the difference is, so output will not depend on only on the state, output will depend on the transition also. In the Mealy machine, what we have, it is also the same 6 tuple. This is the output alphabet, this is the input transitions, these two are different, this is different. So, here it is a lambda is a function of, this will depend on the transition rule, okay, not only on the state, it will depend on the input also, whatever the input we have. So, that is the difference between Moore machine and Mealy machine. So, suppose we are at, so suppose we are reading Q A1, A2, A. So, we are at Q 0. So, suppose by A1 we are going to Q1. So, what will be the output? Output will be, so this is the transition. So, delta of Q 0 A1 is Q1, and say again by A2 we are going to Q2, A3 we are going to Q3 like this. Okay. So, if it is nth length, we are going to Qn after this nth length. So, now this is the input and corresponding state we are visiting. Now, what will be the output? So, input is this A n, and the output will be like this. So, it will be delta of, I mean not delta, this is the lambda of Q 0 A 1, because it is a function of state and the corresponding input alphabet. Then we are at Q 1, Q 1 A 2. So, lambda of Q n, so not Q n, it is Q n minus 1 A n, because this is A n and we are at Q n minus 1. This is the input. Okay. So, this is of length n, this is the sorry, this is the output. This is of length n, this is also of length n. And we have seen one example of this Mealy machine like this. So, say we have 4 state Q 1, Q 2, Q 3, Q 4, and Q 1 is the starting state. So, let us write the transition rules. So, this is for input 0, this is for input 1. So, there are 2 input, and this is say which state it is going, and this is our lambda Q comma 0, and which state it is going, and this is our lambda of Q comma 1. So, suppose it is going to Q 3 the state, and the corresponding output will be say delta of the lambda of Q 1 0 say 0. So, this is Q 1 and it is going 1, Q 2 it is going 1, Q 4 it is going 1. So, similarly, Q 2 it is going 0, okay, and Q 4 it is going 0, and Q1 1 and Q3 it is 0 like this. Okay. So, this is one example where we have this output is also function of this. Now the question is how we can make the equivalence between these two, because so how we can make the equivalence between these two, because this is one length is, suppose we have given a Moore machine and this is a Moore machine, and how to construct a corresponding Mealy machine from a Moore machine, that we will first do, and then we will see they are outputting the same string, because we are their equivalence means they are outputting the same string. So, to see this we have to ignore the first string, because if we have a W which is say 1 A n. Now, for Moore machine what we have, if it is going to say the delta of, this is delta of q 0, this is for epsilon, then delta of q 1, these are the state it is visiting, delta of q n like this. So, here we just omit this and then this will be of length n, and for Mealy machine it is of length n. So, that way we can verify. So, let us do that. Let us take an transformation from the Moore machine to Mealy machine. Given a Moore machine, how we can transfer the, how we can get a Mealy machine, then we can say their equivalence. So, transforming a Moore machine into a Mealy machine. Okay. So, in the Moore machine, in the Mealy machine what we have? In the Mealy machine our the output function is a function of state and the input symbol, but in the Moore machine it is a just a function of state. So, that is the, suppose we have given a Moore machine. So, this is q delta lambda q 0, this is a Moore machine. Okay. So, now here we know the delta is a function of q cross sigma to q, and lambda is a function of q to output alphabet. Now, we have to construct a Mealy machine which is equivalent. So, how to construct that? So, to construct that we just need to change this lambda, that is all. So, this will be q will be same, sigma output alphabet is same, but transition rules is same. Now, this will be lambda hat q 0. Now, how to define this? Yeah, so let me define this here. Okay. So, lambda prime of q 0 a. So, this will be basically lambda of delta of q a, that is all, because this for the Mealy machine this lambda is a function of, lambda prime is a function of q cross sigma to the output alphabet. So, for that we need to take a q from here and we need to take a and we need to give the output. So, output will be same as, so it will reach to some state. So, like suppose we are at say yeah, we are at q 1 or q say this is q, we are at q with delta, suppose we are going to p. Now, with this P where we are going under this. So, that is nothing but our lambda prime q a. This is the way we define. Okay. So, let us take an example. So, actually the Mealy machine, Moore machine is a particular case of Mealy machine. Okay, let us take an example. Suppose we take a Moore machine like this. We have two input alphabet A0, A1 and we have lambda of q. And we have this state q1, q0, q1, q2, q3. There are 4 states over here, and this is the starting state. So, this is q3, the earlier one, 0, earlier example, q2 1 and q2 q3 0 and q3 q0 0. Okay. Now, we want to convert into Mealy machine. So, what will be the equivalence Mealy machine? For equivalence Mealy machine, we then need to have the delta transition. I mean the lambda will be for state and the input alphabet. So, that is very easy. So, we can have say a is equal to 1, sorry, a is equal to 0, a is equal to 1, and here we can have state, and here we can have delta of q, delta prime of q comma 0, and here we have a state and delta prime of q comma 0 and q comma 1. So, we have q 0, q 1, q 2, q 3, and this is going to q 3, and the state will be for q 3 where we are going 0, but it is combining these two. So, this is q 3 0 and again q 1, and it is going to, for q 1 it is going to 1, q 2, for q 2 it is going to 0, and for q 3 to q 3, and it is going to 0 again like this. So, similarly, we can fill up this q 1, q 2, q 3, q 0, and these are all 0 0. I mean straight away the Moore machine is a particular case of Mealy machine, but the reverse is not directly true. The reverse is we have to construct the Moore machine from a Mealy machine. So, that we will do now. So, given a Moore machine, how we can construct a given a Mealy machine, how we can construct a Moore machine, so that they will output the same string for a given input. Okay. So, this is the transforming Mealy machine into a Moore machine. Okay. So, suppose we have given a Mealy machine q, this is the output alphabet lambda q 0. Okay. So, now here lambda is a function of q cross input alphabet to the output alphabet. Okay. So, now to Moore machine I have to construct like this. So, it will be the Cartesian, the state will be Cartesian product of q and the output alphabet set, because it is going to the output alphabet set. This is same, then this will also change lambda prime, and the starting state is q 0 and the pair q 0 and b 0, where b 0 is the arbitrary element selected from this. So, b 0 is coming from this. Now, what is the rule? How we get the rules? Rules are we can define here. So, basically we have to define the delta prime. So, delta prime is what? Delta prime of, now q 0 will be of this form or any state of this form q comma b, because this is a Cartesian product of this with a. So, where it is going? It is going to, the state is changing, state is going to delta of q comma a, this is the state change, and the output lambda of q comma a. Okay. And this is again a subset of q comma q cross output alphabet set. And then this is B, where q is coming from state and B is coming from, B is a alphabet set, output alphabet set, and q is a state and A is a input alphabet. So, this is the way we define this. Okay, so, let us take a quick example. So, we have given, suppose we have given the Mealy machine, which is a this is our delta and these are our state q 1, q 2. They say there are 3 states only, and this is our delta transition with a is equal to 0, a is equal to 1, and this is the lambda of q comma 0, and so this is say this is going to say 2 and this is z 1 say, sorry, this is lambda of q comma 0, this is going to z 1, this is say q 2 and this is also q 2, this is z 2, this is q 2, this is z 1. These are the output alphabet, and with a is equal to 1, these are the states and these are the lambda. So, states are going to say q 3, q 3, q 3 and lambda is say z 1, z 1, z 2. Okay. Now, if you draw the corresponding Mealy machine, it will be like this. Sorry, this is the Mealy machine. Now, if you draw the corresponding Moore machine, it will be like this. So, like this. So, we have delta prime. So, delta prime. So, we have our states are basically what? The states are basically for the new states is this q comma output alphabet. So, all states are of the pair of say q comma some z I. So, if we do this, then the corresponding Mealy machine, a Moore machine will be like this q comma a. So, this is our transition rule 0 1 and this is our okay. So, q 1 z 1, this is the starting symbol. It is going to you can verify this q 1 z 1, q 2 z 2 and this is q 3 z 1 and this is going to z 1. Okay. And then we have q 3 z 1, you can easily verify this, and q 3 z 3 sorry Q2 Z2 and this is Z2, no this is Z1. So, like this we continue. So, Q2 Z1 and then we have Q2 Z1, Q2 Z2 and this is Q3 Z1, Z1. Like this we can continue this to fill up this table, and this will we can show that this will accepting the, this is outputting the same string, omitting the first alphabet, first output, but here we do not need to omit, the way we constructed it will output the same string as the 2 machine. And then we can have this some more example on this equivalency, which will be given in the lecture note. Thank you very much.